Chapter 5 of the Airlords of Han by Philip Francis Nowlan. This LibriVox recording is in the public domain. Chapter 5 American Ultronic Science. Our own engineers, working shielded laboratories far underground, had established such control over the deatomized electrons as to dissect them in their turn into subelectrons. Moreover, they had carried through the study of this order to the point where they finally dissected the subelectron into its component ultrons, for the fundamental laws underlying these successive orders are not radically dissimilar. And as they progressed, they developed constructive as well as destructive practice. Hence the great triumphs of ultron and inertron, our two wonderful synthetic elements, built up from superbalanced and subbalanced ultronic whirls, through the subelectronic order and into the atomic and molecular. Hence also came our relatively simple and beautifully efficient ultraphones and ultrascopes, which in their phonic and visual operation penetrate obstacles of material, electronic and subelectronic nature without let or hindrance, and with a consumption of but infinitesimal power. Static disturbance, I should explain, is negligible in the subelectronic order and non-existent in the ultronic. The pioneer expeditions of our engineers into the ultronic order, I am told, necessitated the use of the most elaborate, complicated, and delicate apparatus, as well as the expenditure of most costly power. But once established there, all necessary power is developed very simply from tiny batteries composed of thin plates of metultron and catultron. These two substances, developed synthetically in much the same manner as ordinary ultron, exhibit dual phenomena for which, for sake of illustration, I may compare with certain of the phenomena of radioactivity. As radium is constantly giving off electronic emanations and changing its atomic structure thereby, so catultron is constantly giving off ultronic emanations and so changing its subelectronic form, while metultron, its component, is constantly attracting and absorbing ultronic values, and so changing its subelectronic nature in the opposite direction. Thin plates of these two substances, when placed properly in juxtaposition, with insulating plates of inertron between, constitute a battery which generates an ultronic current. And it is a curious parallel that just as there were many mysteries connected with the nature of electricity in the 20th century, mysteries which, I might mention, never have been solved, notwithstanding our penetration into these sub-orders, so there are certain mysteries about the ultronic current. It will flow, for instance, through an ultron wire from the catultron to the metultron plate, as electricity will flow through a copper wire. It will short-circuit between the two plates if the inertron insulation is imperfect. When the insulation is perfect, however, and no ultron metallic circuit is complete, the current, apparently the same that would flow through the metallic circuit, is projected into space in an absolutely straight line from the catultron plate, and received from space by the metultron plate on the same line. This line is the theoretical straight line passing through the center mass of each plate. The shapes and angles of the plates have nothing to do with it, except that the perpendicular distance of the plate's edges from the mass center line determines thickness of the beam of parallel current rays. Thus a simple battery may be used either as a sender or receiver of current. Two batteries adjusted to the same center line become connected in series just as if they were connected by ultron wires. In actual practice, however, two types of batteries are used, both the FOSO batteries and broadcast batteries. FOSO batteries are twin batteries arranged to shoot a positive and a negative beam in the same direction. When these beams are made intermittent at light frequencies, though they are not light waves, nor of the same order as light waves, and are brought together or focused at a given spot, the space in which they cross radiates alternating ultronic current in every direction. This radiated ultralight acts like true light so long as the crossing beams vibrate at light frequencies, except in three respects. First, it is not visible to the eye. Second, its color is exclusively dependent on the frequency of the FOSO beams, which determine the frequency of the alternating radiation. Material surfaces, it would appear, reflect them all in equal value, and the color of the resultant picture depends on the color of the phoso frequencies. By alternating these, a reddish, yellowish, or bluish picture may be seen. In actual practice, an orthochromatic mixture of frequencies is used to give a black, gray, and white picture. The third difference is this: rays pulsating in line toward any ultron object connected with the rear plates of the twin batteries through rectifiers cannot be reflected by material objects, for it appears they are subject to a kind of pull which draws them through material objects, which in a sense are magnetized, and while in this state offer no resistance. Ultron, when so connected with battery terminals, glows with true light under the impact of ultralight, and if in the form of a lens or set of lenses, may be made to deliver a picture in any telescopic degree desired. The essential parts of an ultrascope, then, are twin batteries with focal control and frequency control, an ultron shield, battery connected and adjustable, to intercept the direct rays from the glow spot, with an ordinary light shield between it and the lens itself, battery connected, and with more or less telescopic elaboration. To look through a substance at an object, one only has to focus the glow spot beyond the substance but on the near side of the object and slightly above it. A complete apparatus may be set for penetrative, distance, and normal vision. In the first, which one would use to look through the forest screen from the air, or in examining the interior of a Han ship or any opaque structure, the glow spot is brought low at only a tiny angle above the vision line, and the shield, of course, must be very carefully adjusted. Distance setting would be used, for instance, in surveying a valley beyond a hill or mountain. The glow spot is thrown high to illuminate the entire scene. In the normal setting, the phoso rays are brought together close overhead and illuminate the scene just as a lamp of super brilliancy would in the same position. For phonic communication, a spherical sending battery is a ball of metultron, surrounded by an insulating shell of inertron, and this in turn by a spherical shell of katultron, from which the current radiates in every direction, tuning being accomplished by frequency of intermissions, with audio frequency modulation. The receiving battery has a core pole of katultron and an outer shell of metultron. The receiving battery, of course, picks up all frequencies, the undesired ones being tuned out in detection. Tuning, however, is only a convenience for privacy and elimination of interference in ultraphonic communication. It is not involved as a necessity, for untuned currents may be broadcast at voice-controlled frequencies directly and without any carrier wave. To use plate batteries or single centerline batteries for phonic communication would require absolutely accurate directional aligning of sender and receiver, a very great practical difficulty, except when sender and receiver are relatively close and mutually visible. This, however, is the regular system used in the intergang network for official communication. The senders and receivers used in this system are set only with the greatest difficulty and by the aid of the finest laboratory apparatus, but once set, they are permanently locked in position at the stations, and barring earthquakes or insecure foundations, need no subsequent adjustment. Accuracy of alignment permits beam paths no thicker than the old lead pencils I used to use in the 20th century. The non-interference of such communication lines, and the difficulty of cutting in on them from any point except immediately adjacent to the sender or receiver, is strikingly apparent when it is realized that every square inch of an imaginary plane bisecting the unlocated beam would have to be explored with a receiving battery in order to locate the beam itself. A practical compromise between the spherical or universal broadcast senders and receivers on one hand, and the single-line batteries on the other, is the multifacet battery. Another and more practical device, particularly for distance work, is the window spherical. It is merely an ordinary spherical battery with a shielding shell with an opening of any desired size, from which a directionally controlled beam may be emitted in different forms, usually that simply of an expanding cone, with an angle of expansion sufficient to cover the desired territory at the desired point of reception. End of chapter 5.